Okay, so I have 5x to the fourth over 8x squared y squared, and then I multiply by the reciprocal, so times 8y to the fifth over 15. Okay, so my 5 and my 15 reduce to 3. My 8 and my 8 cancel. I have x to the fourth over x squared, so that's going to be x squared on top, nothing on the bottom. And then I have y squared and y to the fifth. Y to the fifth's on top, so that's going to be y to the third, and then nothing on the bottom. Okay, so when I multiply across, I have x squared, y cubed, and then everything's gone on the bottom except for 3. Okay, so that's how you got that. Okay, so the next one, so we're going to have to factor everything completely as we're doing this. So the top is x to the fourth minus 9x squared. So that means I can pull out an x squared, so the GCF, and I have x squared minus 9 left, which that's actually going to factor further. On the bottom, I have x squared minus 4x plus 3, so that's going to be x minus 3 and then x plus 1, or x, both of them minus, right? So x minus 3, x minus 1. All right, now I'm going to multiply by the reciprocal. So multiply by the reciprocal. So when I do that, my x squared minus 16 is now on the top, and it factors as x plus 4 times x minus 4. And then my denominator is looking kind of weird. It's x to the fourth plus 2x cubed minus 8x squared. So what do I need to do first? Right, pull out the GCF, so x squared. So I'd have x squared plus 2x minus 8. Okay, right now it's looking like nothing's really canceling, just the x squareds, that's it. Okay, but I noticed that I have x squared minus 9, so that's going to factor, so let's go one more step. So I'm going to factor the x squared minus 9, so I get x plus 3 times x minus 3. Your denominator is still x minus 3 times x minus 1. The numerator on the other side is still x plus 4 times x minus 4. And then it looks like this denominator factors as well. So I'm going to get x minus 2 times x plus 4. Okay, now there's going to be several things that cancel. So the x minus 3's, the x plus 4's. So you can write your answer in two different ways. You can leave it as x plus 3 times x minus 4 over x minus 1 times x minus 2. So I don't mind that. That's fine. That'll actually be helpful later on when we're graphing to see it in the factored form. Or you can multiply it out. So when you multiply it out, FOIL it out, so I get x times x is x squared. My outer is negative 4x, and my inner is plus 3x. So that makes negative x when you combine them. And my last is 3 times negative 4, so negative 12. All over, x times x is x squared. My outer is negative 2x, my inner is negative 1x, and minus 3x. My last is plus 2. Okay, so write it like that. All right, I always have people always ask me a question. They say, well, would I then factor and try to see if there's anything in common? But what happens if you try to factor that? You got the same thing that you just multiplied out. There's only one way to factor those things. So that's it. That's as far as you can go. Okay, so the last one? Yep, 2 more. All right. Okay, it says you can solve rational equations, but make sure you check your solution. Remember, some numbers could have made the original rational expression undefined. Okay, so there's 2 ways to do this. So you can wait until I write the shortcut if you want, but here's the long way. Your long way is taking the x minus 5 and multiplying it over with the 14. So when you do that, you get x squared minus 25 equals 14 times x minus 5, which multiplies out, so you get 14x minus 70. Okay, you have x squared and x terms, so get them all on one side. So I'm going to have x squared. I'm going to subtract the 14x over. I'm going to add the 70 over. So you get that. We know to solve things like that, we factor. So I get x minus 9 times x minus 5 equals 0. So set each piece equal to 0 and solve and get x equals 9 and x equals 5. Okay, but when you go back and check in your original, 9 works. It will work out. It makes 14. But what about 5? Yeah, you get 0 over 0 equals 14 when you check. Okay, and that doesn't work. 0 over 0 is undefined. We don't know what that is. So that means 5's gone. It's not an answer. 9 was your only answer. Okay, so I'm saying that there's a shortcut. So the shortcut is to look and see if anything factors. So when you look at x squared minus 25 over x minus 5, what do you guys see happens? Yeah, Anthony? Yep. Yep, so he saw it was a perfect square and the x minus 5's cancel. So this is a much easier equation. X plus 5 equals 14. Because then I see that x equals 9. Okay, and you can check that one. That one works. So that's the only one that works. Does it work? Yeah, 81 minus, okay. Now the next one. So let's say we do the shortcut on this one. So I'm going to factor. So when I factor, I need x minus 2 times x plus 5, right? They need to multiply to be a negative 10, and the outer and inner combined to be plus 3x. All right, the x minus 2's cancel. Now this doesn't always happen. Like there's going to be polynomials that aren't going to cancel on the top and the bottom. If they don't, you do it the long way. But in this chapter, we're going to do a lot of factoring, so I'm guessing a lot of the problems you're going to do are going to cancel. All right, so you get x plus 5 equals 7, so we get x equals 2. But just because we did the shortcut, that doesn't mean that that's the answer. So if you go back and check this one, what happens? Yeah, you get 0 over 0, right, equals 7. So this is another one of those ones that doesn't work. So 2 doesn't work, and if I had done it the long way, the other thing wouldn't work. So what happens? Yep, you're right, no solution. Good. Okay, so any questions on 9-1? Okay, makes sense.